Okay, let's take a minute to talk about angles of elevation and depression. An angle of elevation is the angle from the horizontal looking up. So if you are standing on the ground, then the ground is the horizontal, or if there's a building down there or something similar, whatever it is, it's from the horizontal looking up. So if you are looking, if the problem says it's from your eyes looking up from where the person is standing, then that eye level becomes the horizontal. And with this kind of thing, that's when you try and find things like the height of a tree. Say if you're standing at the base, or if you're 100 feet away and you want to find out what the height of a tree is, this is what you're going to use. You're going to use the angle of elevation. Or if it's the height of a building, then you're going to use the same kind of thing. Or you could say if you're standing on the ground and you want to know find the distance from somebody to a building, and it gives you the height of the building, then you can use that as well. Remember to use these, it's just the simple sine, cosine, or tangent that you're going to use to find any of the missing pieces when they give you an angle of elevation. If you're trying to find the angle of elevation, then you have to use the inverse of sine, cosine, or tangent, whichever information that they give you. You can also discover how tall or how far away from the ground, how high is a kite or something like that. That's angle of elevation. Angle of depression is the other side. It's the angle from the horizontal looking down. Now, this can be kind of tricky for some people because we'll show you some examples before, but when you are looking down, it's not straight down to the ground. This from the horizontal, if your its eye level is the horizontal. Again, if you're standing up and your feet are the horizontal, and this angle here is the angle of depression. So you want to be really careful about that. Let's look at some examples. Well, here is our horizontal. Let's just say if we are looking from our horizontal down at something, we have an angle of depression that is 30 degrees right here. But if we are looking for how far they are apart, this mailbox from this building, what is this distance, then you need to switch your angle. You can't use your angle, this angle, for that. It's the other side. It's 60 degrees. If you want to, this distance right here is going to be the same as this distance up here, so you can use it, but you have to make sure that you understand what you are trying to find. So basically, there are two different triangles that you can use here. One of them is going to be this one, and the other one is going to be this one. But it's in a completely different space up here. So you can use either one of these. You just have to make sure that you know what all of your pieces are, and that you know that this angle right here, the whole thing being a rectangle, is going to be 90 degrees. So if it gives you the angle of depression, you might have to find the other side. Now if you have something like this, and it says two buildings are 60 feet apart across a street, a person on top of the shorter building finds the angle of elevation of the roof of the taller building to be 20 degrees. So if a person is standing on the shorter building, here is the horizontal right here. If they say that the angle of elevation to the top of this building is 20 degrees, well, that's going to be from the horizontal up. If it says the angle of depression of its base is 30 degrees, that's from the horizontal going down to the base of the big building. So we've got 20 degrees and we've got 30 degrees. They want to know how tall is this taller building. Well, we know that they're 60 feet across, so we can use that. That's our horizontal distance. So now we have two pieces of this triangle, and we have two pieces of this triangle, because we can use our 60 feet right there. So try and keep track of where your horizontal is. That is the key to all of these problems. Now here's my favorite one. I love this one. From the top of a vertical cliff 40 meters high, The angle of depression of an object that is level with the base of the cliff is 34 degrees. How far is the object from the base of the cliff? Now, you have to understand, this is a very simple drawing I just got online. So this cliff should continue straight down. It's a vertical cliff. So here we have our angle of depression is 34 degrees. That is this one right here, our angle of depression, because this is our horizontal. Do not, again, get lost trying to find your horizontal. And then that means that the other side is going to be 90 minus 34 degrees, and that's how we are going to find this other angle. But we're looking for how far is the object from the base of the cliff. So here's my little object. It is this distance is what we're looking for. Well, this distance is the same as this distance. And it says that the vertical cliff is 40 meters high. That means this distance is the same as this distance. So you can use either angle. You just have to make sure you are finding the right thing. So here we could use 34 degrees, and we don't have a hypotenuse, but we have 40. If it's the opposite over the adjacent, then we're going to have to use the tangent of 34 degrees is 40 over x. Down here, it's going to end up being the 90 minus 34, which happens to be 56 degrees. So it will end up being equals 56. So it will end up being, we're going to use this height over here. It's still 40 meters, and it's the opposite over the adjacent, but it's going to end up being x over 40. So you're going to have to be careful with those two. All right, I hope this helps a little bit, because we're going to have more of these kinds of word problems.